Okay, it says researchers investigated how the size of a bowl affects how much ice cream people tend to scoop for themselves. People were randomly either given a 17-ounce or a 34-ounce bowl and were invited to scoop as much ice cream as they liked. Did the bowl size change the selected portion size? The summaries are shown to the right. Test an appropriate hypothesis. Okay, we just want to know if it depended on the bowl size, how big how much your scoop was. So we're going to look at the difference between large and small. The null hypothesis is always that it's equal to 0. And the alternative should be that it's not equal to. So I should actually choose A. And now we'll compute the t statistic. So we're going to go into our Excel spreadsheet that only works in Excel 2010. And we'll put in the first mean. We wanted to do large minus small. So this is going to be, the first mean is the 6.77. And the standard deviation is 3.02, and the sample size is 23, and then the second sample mean is 5.38, and the second sample standard deviation is 1.98, and the second sample size is 22, and they said at alpha level of 0.90, which corresponds, I'm sorry, at 0.10, which corresponds to a 0.9 in your not equal to your two-tailed hypothesis test. Okay, so your t-value is 1.833, 1.83 rounded to 2 decimal places. Okay, now your t-star is right here, and it's going to be 1.69. Okay, and then your p-value for the not equal is right here, 0.07. Let's see, that'll be 3 decimal places, so 0.075. Says state the conclusion. This is a pretty large p-value, so we are going to fail to reject the null hypothesis. There is insufficient evidence that the bowl size changes to portion size, and we can look at our null hypothesis, our confidence interval as well. Well, I don't know. See, that's a little tricky because in our confidence interval, well, 0 is not in the interval, so it kind of feels like we would fail to reject. But I don't know. This is a little tricky with that p-value that large. Let's see what they decide. Well, I'm sorry. I can answer this question. The alpha level, the significance of 0.10, which is actually a pretty big alpha level. When you have that, what you do with your alpha level is you look and you see, is my p-value less than my alpha value? If it is, then you are going to reject the null hypothesis, and there is evidence. But I would argue that this is actually kind of a big p-value, but that's why I always like to report the p-value. But to get the answer right, we're going to have to reject the null hypothesis because our p-value is less than the significance level of 0.10. Okay, and that's it.